Okay, today's lesson is 4.1a, right triangle trigonometry, and we are going to have a really quick, short review of what you have already done before. So in case you don't know, it might be helpful to know that trigonometry actually comes from the Greek word, which means triangle measure. So all we're doing is studying triangles and their measures and their angles. Excuse me, and you will see applications of them. So what you did last year and the year before in trigonometry is you started off with, or you learned a relationship between the sides and the angles, and you had a mnemonic device often referred to as SOHCAHTOA. Some people write out all the letters next to each other, but I kind of like it written like this because it helps you remember what things stand for. So SOH tells you that the sine of an angle is equal to opposite over hypotenuse. CAH, cosine of an angle, is adjacent over hypotenuse. Tangent is opposite over adjacent. And you also learned last year that there were three reciprocal functions, and they are actually written right next to, on the same horizontal as their reciprocals. So the cosecant is going to be hypotenuse over opposite, secant is going to be hypotenuse over adjacent, and cotangent is going to be adjacent over opposite. So what do you have to do? Find the exact value. So this is something you really need to pay attention to, especially in delta math. The exact values means you're not given any decimals. The only thing you got to do is basically remember to reduce your fractions or rationalize your denominators, as you see when we go through. So in this first one, theta is right here. And so if that is theta, then we know that opposite is 5, 12 is adjacent, and 13 is hypotenuse. Hypotenuse is always opposite the right angle, okay? And so when you have two sides that are adjacent to it, one of them has to be the hypotenuse, and it's opposite the right angle. So then the opposite side does not make the angle, okay, to help you remember. All right, so the sine is going to be opposite over hypotenuse, and the opposite is 5. Hypotenuse is 13. Cosine, adjacent over hypotenuse, 12 over 13. Tangent, opposite over adjacent, that's 5 over 12. And I put them right next to each other, okay? This is what you want to do. And I mentioned before, notice that the first letter of these two are not the same. S and C, here, S and C. So the reciprocal doesn't start with the same letter. So, again, easy. Cosecant, I'm just going to flip it. 13 over 5. Secant, 13 over 12. Cotangent, 12 over 5. That's all you have to do. So I work out 1B on the notes. If you want to see it, you'll look at it. If you have any questions, come see us. Okay. Use one trigonometric value to find others. So in this particular case, they are giving us one value. Tangent of theta is equal to 1/2. And we're going to go find the exact values of the other 5 remaining trig functions. So tangent, you know, is opposite over adjacent. Okay, neither of those is the hypotenuse. So you're going to set up your Pythagorean theorem to find the third side. So that's going to be 1 squared plus 2 squared equal to c squared. If you think about a squared plus b squared equals c squared. So c squared equals 5. And c equals plus or minus the square root of 5. Now that is the case whenever you solve a triangle. It is a triangle that we're dealing with here, so we don't need the negative in this case, okay? So the first one I write is the actual reciprocal of the one they were giving us. So the reciprocal of 1/2 is 2. Now sine is opposite, which is 1 over the square root of 5. Now, you cannot, I didn't mean to do that, sorry. You cannot leave a radical in the bottom. So when you write it as 1 over the square root of 5, you've got to remember to rationalize that. And you multiply by the square root of 5 over the square root of 5, which gives you the square root of 5 over 5. Cosine is going to be adjacent over, that's adjacent is 2 over the hypotenuse, which is the square root of 5. So 2 over the square root of 5, again, rationalized, is going to give us 2 square roots of 5 over 5. Now, if you put this into class calc, it will give you this answer. So you don't even have to worry about it. So a lot of y'all have calculators that do that for you, but just know and remember, you can't leave a radical on the bottom. Now, the reason I write it like this, because it makes it a lot easier when you have to go get the reciprocal, because all I have to do is flip this one. So that's going to be the square root of 5, and the next one's going to be the square root of 5 over 2. And that's all we have. Okay? All right. Quick review. Here are your special right triangles that you learned. X squared to 3, 2x on a 30, 60, 90 triangle. 45, 45, 90, you got x, and x times the square root of 2. These are all their trig functions, but we're going to talk about those again later, so I'm going to keep on going. All right, number 3, find the value of x. Round to the nearest tenth. Okay? So, again, I'm just going to do this first one. If you want to see the second one, you can look at the notes. Come ask me questions if you have any. So, if I'm looking for x, I'm going to, and this is my angle. Okay, then these two sides can be defined according to that angle. Well, x is across from the right angle, so it is the hypotenuse. 15 is across from the original angle, so it is opposite. So the trig function that deals with opposite and hypotenuse is the sine function. So I'm going to have the sine of 53 is equal to opposite, which is 15, over x, or over hypotenuse, which is x. Now, I'm going to tell you a really easy way to solve these things, y'all, in one step. Okay? If the x is on the bottom, you're going to switch these two. That's what our properties of proportions tell us. So I always do a little arrow to say to myself, I'm going to switch them. So x is equal to 15 divided by the sine of 53. Put it into class calc, whatever calculator you use. If you, actually, you're safe with that. Let's keep going. So x equals 18.782. Rounded to the nearest tenth is going to be 18.8. All right, last example, real world problem. We got to do some of those. Suppose a competitor in the swimming portion of the race is swimming along the course shown. Find the distance the competitor must swim to reach the shore. So I have an angle, and I have a side. I obviously have 3 sides, but this side is opposite the right angle. So that's my hypotenuse, which makes this side my adjacent and this side opposite. And what trig function deals with opposite and adjacent is your tangent function. So I'm going to have the tangent of 48 equal opposite, which is x, over adjacent, which is 75. This time, my variable's in the top. So back up here, my variable's in the bottom, I switch them. Okay, so in essence, if the variable's in the bottom, I'm dividing the two numbers. And if the variable's in the top, then that means I can multiply both sides by 75, which moves that into the front, which means that x is equal to 75 times the tangent of 48. So one of them you divide, one of them you multiply. Easy to know if you draw your arrows there. So put that in your calculator. X equals 83.2959. And we're going to just round to the nearest tenth because it's not a whole number. And they didn't give us directions. So we got 83.3 feet. And that is all that we have to the first part of trigonometric functions. Right triangle trigonometry. Thank you so much. Y'all have a great day.